Now, these remaining questions involve the Suvat formulas. So, it says a truck starts from rest and travels 300 meters in 4 seconds. We want to know its final velocity and its acceleration. So, starting from rest, that implies that u equals 0. The acceleration, we don't have it. We know that it covers a distance s equal to 300, and the time is 4. So let's write down what we have. We have s, u, v, a, t. Suvat. S is 300, u is 0, v is unknown, a is unknown, and t is 4 seconds. Now what we're going to do is we are going to go ahead and set up our Suvat equation. Determine its final velocity. Let's try to use the velocity equation. So v equals at plus u. Let me plug in what I have. V is unknown, so I'll leave it as v. A is unknown, so I can't use that. T is 4, and u is 0. So this equation, we tried it, and it doesn't work. All right, let's try the next equation. Now we will try s equals 1/2 at squared plus u times t. And so we have 300 equals 1/2 times a times 4 squared plus 0 times 4. We can simplify. We get 300 equals. When I simplify this here, I can use the commutative property and the associative property and PEMDAS. That's going to give me 8 times a here when I simplify. I'll divide both sides by a, and so I'm going to get 300 divided by 8 as my acceleration. Let me actually simplify that. So that's 37.5 meters per second squared. So there's my A. Now I can go back and use this in the velocity formula. So I will say v equals at plus u. So that's v equals 37.5 times 4 plus 0. And so when I solve for v, I will end up getting 150 meters per second. So you notice here, this didn't work at first. It doesn't work yet. I use it later. And that's how we do that. Okay? Now, an object falls from a cliff at rest. How far does it fall after 6 seconds? And what is its final velocity? One small thing. When things fall, please be careful. Notice the acceleration due to gravity is going to be 10. So let's be really, really careful. So let's do our Suvat. S, U, V, A, T. S, we don't know. U is 0. It falls from rest. V is unknown. A is 10. And T is 6. I'm just going to blow this up a little bit so we can see a little bit better. There we go. Now, that's seconds. So how far does it fall after 6 seconds? Let's try S is 1/2. AT squared plus UT. So that's S equals 1/2 times 10 for gravity times 6 squared plus 0 times 6. That'll just be 0. So when we actually simplify this in our calculator, I believe that's going to be 180. Sorry. So this is 180 meters. Now let's get its final velocity. Let's try v equals AT plus u. So that's v equals 10 times 6 plus 0. So v ends up being 60 meters per second. Now, this is very obnoxious. It says a ball this. Y'all, this is a really tough one. I'm going to put a star there. A question this hard would probably be a bonus question. I don't think I would put something this tricky on the test, and here's why. I throw the ball up into the air. So there's sorry. V at the top is 0. And let's be clear, the acceleration here is -10 because it's downward acceleration. And that negative, because it's downward, that's a bit tricky. Okay, plus S is 10. So let's just get the initial velocity. We don't have the time. So I'm going to use this formula. V squared is u squared plus 2 times A times S. 0 squared is my unknown u squared plus 2 times my acceleration of -10 times S, which is also 10. So that gives me u squared equal 0 squared equals u squared minus 200. We will add 200 to both sides. And that's going to give me 200 equals u squared. And so when I simplify that, I believe it's going to be about 14.1. So I take the square root of both sides, and that's going to give me u equals 14.1 meters per second. So that's question number 7. We'll take a look at question number 8 in the last video.